already 6 to. I will be waiting 2 more minutes. Since participants are still joining, after once they join, I will start the session. Am I audible? You can type it in the chat messages. If my audio is not clear, I will try to. Okay, thank you. Okay, it's already 6:04. So I will be starting the session. I will share the screen. Please let me know if my screen is visible properly. Okay, I think now it is visible, right? Okay, I will start the session. Hello, all. My name is Srihari. I am the teaching assistant for the advances in welding and joining, especially for NPTEL problem solving session. And the course tutor for this course is, as you know, it's Professor Sarun Box. And this is the first live session. This is the first live session. So now I will be starting my presentation. Okay. Before that, this is first week live session. So I can't able to discuss about the first week assignment since the deadline is not yet completed. So I will be discussing the prerequisite and some basic arc welding process. Just to give the basic understanding about the arc welding process, and then I will discuss about the this week 0 prerequisite questions in little bit in detail. So first of all, welding arc is classified into like autogenous welding and deposition welding. Autogenous welding in the sense where uh, the electrode won't melt with the help of with the help of the arc generated between the electrode and the base plate. The heat will be generated. If it is thin sheets, it will melt those thin sheets and covalence will happen, and joining of the metal will happen. In deposition process, where electrode will be the consumable electrode, where the electrode will melt and deposit. Uh, Along with the deposition, the arc which is present between the electrode and the base plate is used to melt the base plate, melt the substrate to join this process. Means in autogenous welding, there are non-consumable electrode will be there. In deposition welding process, consumable electrode will be there. In autogenous welding, mainly GTAW process, plasma arc welding process, and whereas in deposition in general, shielded metal arc welding, gas metal arc welding, and submerged arc welding, and many other processes are also there. Since it is prerequisite, I'm just giving brief video. 1 second, someone is joining the session, I think. My screen is visible, right? Okay, sorry for okay. Since it is a prerequisite, just I am giving the brief idea about the welding, electric arc welding, basically which comes under fusion welding. So GTAW and plasma will be the autogenous welding, and deposition welding where shielded metal or gas metal arc welding and submerged arc welding. As you can see in this figure, the electrode is getting melted and deposited along with the arc. Here there is only a arc which with the help of that heat it will melt the substrate to join the metal. If the thickness of the material is if the thickness of material is more larger, then will supply the external filler wire which will be used for the joining process. So first of all, in this figure 2 explains the gas schematic of the gas tungsten arc welding process, where this is the electrode and this is with the base plate. With the help of the potential difference, the arc will be generated. Once the arc is generated, the electrons will flow based on the polarity, and deposition will start. One second. Deposition will start. Here, as I said earlier, as the name suggests, gas tungsten arc welding. Here, non-consumable electrode tungsten is used, and shielding gas is used to protect the molten pool and the filler molten pool and the molten pool from the atmosphere. I think settings needs to be changed. Actually, everyone is asking me to join. Okay, I will start the session next class and also I will change the session. And now the shielding gas argon or helium is used to avoid the atmospheric contamination for the molten pool. Means basically the base plate is getting melted, which will get oxidized if it is exposed to the atmosphere. For that, the shielding gas is supplied through this, which will be used to avoid the atmospheric contamination. As I said earlier, if the thickness of the joint is more, then we will supply the external filler wire as seen in this figure. This is the filler wire. If the thickness of the material needs to be is more, then filler wire is used. Then shielded metal welding. This is the common welding which we use, which generally we see in construction site or even in roadside, in the roadside also. As the schematic explains, the electrode will be coated with some coatings. uh, Here it's a consumable electrode, means electrode will melt. Along with the electrode melting, the coatings which is coated to the electrode will also melt, which will generate the slag and also the gases. These gases will protect the atmospheric contamination of the molten pool. Earlier we have used as shielding gas, whereas here we have used coatings. Because of the melting of the coating, gases will be generated, which will form a solidified slag to protect the already solidified metal and also the molten pool from the gases, which is due to the melting of the coatings. So here the coatings are used. Uh, this is shielded metal arc welding process, and similarly gas tungsten arc welding process, uh, gas metal arc welding process. As the name suggests, here metal in the sense we electrode will be like any consumable electrode. So based on the material requirement, we'll use this suitable electrode, and the arc is stuck between the electrode and the base plate. Since it is a consumable electrode, it will melt and it will deposit. And here, as in the case of GTW, here also we are supplying the shielding gas, which will use to ionize the ionize the arc and also protect the welding molten pool from the atmosphere. This is also mostly used in most of the applications, like you can use it in automobile industries and many other industries. So since it is a consumable electrode, we can use it for thicker metals compared to GTAW process. This is GMAW process. Next time I will be explaining the submerged arc welding process. As you can see here, submerged arc means arc is submerged under a granular flux, as the name suggests. Means Here we are not using shielding gas or any coatings to the electrode. Here the granular flux is submerged, protects the arc and the solidified material from the atmosphere. Means the slag will be over the arc. The arc generated between the electrode and the base plate is used to melt the electrode and deposit. And the granular flux, which is over the arc, is getting melted and forms the solidified slag, and the deposition happens. Here the current ranges from even 400 to 1000 amps, whereas in GTAW and GTAW and MIG process, generally current ranges from 100 to 400 amps. So submerged arc welding is used mainly for thicker plate welding. So this is the brief introduction of the electric arc welding process. Means basically fusion arc welding process. In that, I am explained about the arc welding processes. These are the four brief idea. So next, in the prerequisite, there were the questions. So we'll see how to solve those questions. One second. Okay. Which one of the welding process is not associated with the fluid flow material within the weld pool? So the question is, fluid flow molten metal material is not involved. Means obviously it should not be a fission welding. So basically in fission welding, these are the processes like shielded metal arc, as I explained now, gas metal arc, gas junction. Means the temperature of the because of the arc generation, the uh, temperature will be the more than the melting point of the temperature. One second, someone is getting joined. Okay. Uh, so the question, sorry again. So the question is like, in which of the processes fluid flow of the molten metal won't be there? So gas junction arc welding. So first we'll check the options: gas junction arc welding, friction stir welding, laser welding, and gas metal arc welding. So gas junction arc welding, gas metal arc welding, laser welding, all comes under the fusion weld process. Means a fusion of the means the electrode is also melting, or base plate is melting. Means temperature is generated is more than the melting point. So obviously fluid flow of the molten metal will be there. Whereas in friction stir welding, it is like a solid state welding, where there is no melting of the temperature generated is not more than the melting point of the material used. So option B will be the answer. If you guys have any doubt, please text me. Please chat in the chat box. I can check it and I can reply this back. After each question, I will check the this thing. And if you have any doubt, you please chat. Chat it. So as I said, since uh, option A, B, and D comes under fusion welding process, where the melting point will, where the temperature generated on the material is near the joining is more than the melting point, so it will get melted. So obviously, fluid flow of the molten metal will be there. So in friction stir welding, there won't be any temperature generated is less than the melting point. So option B is the answer. So next question: in which one of the joining process the weld joint strength is maximum? Okay. First of all, what are the options given? Brazing, soldering, adhesive binding, and fusion welding process. Okay. Brazing and soldering. Here the temperature will be like around 450 for brazing and soldering. 450, 500, something like that. So here the filler material used, it will get melted, and based on the wetting and joining action, bond will be formed. So strength will be less compared to the fusion welding process, because here metal is getting melted, the material is getting melted and getting joined. And also in adhesive bonding, we'll use extra adhesive to melt the two, or we'll use the adhesive to join the two materials given. So here also the strength will be dependent on the adhesive we use. So obviously, strength will be less compared to the fusion welding process. So the answer will be like first, second question answer will be like fusion welding process. So, because here the metal is getting welded, so the strength will be more. If you guys have any doubt, please write it in chat on. Okay. In next question, in which one of the following welding process the maximum temperature is achieved for joining of a particular material? The options given are laser welding, ultrasonic welding, friction stir welding, brazing, and soldering process. Can anyone answer for this in the chat box? The options given are means the question is the which maximum temperature is achieved for joining of the particular material in which of the welding process? Laser welding, ultrasonic welding, friction stir welding, brazing, and soldering process. Actually, this is very straightforward. Someone has stated ultrasonic welding. Okay. Actually, the answer is laser welding, because laser welding is a high energy beam welding where the arc is concentrated at a particular point. Uh, so, uh, so the temperature achieved at that particular point will be more than the other welding process, whether it is friction stir or ultrasonic welding, because these are comes under solid state welding. In solid state welding, the temperature will be less, and this, as we know, in brazing and soldering, the temperature is hardly around like 400 to 450 or 500, something like that. But in laser welding, since the high energy arc is concentrated at a particular point, the melting the temperature reach will be very high, and since it is a high energy beam welding process, so obviously the temperature achieved will be more. So the option is A for third one. Do you guys have any doubt, please? Since no one has posted anything, so I'll proceed further. Next question. Solidification process is associated with the which process? Gas tension arc welding, friction stir welding, diffusion welding, ultrasonic welding. This question is some kind of similar to this question. First question. Like solidification process means first of all the material needs to be get melted, right? And later it needs to be solidified. In the option 5A is the answer, means gas junction arc welding, where the melting point reaches more than the temperature for the material reaches more than the melting point. So gas junction arc welding will be the answer, and because friction stir welding, this all comes under solid state welding, where the material won't get melt. So answer is gas junction arc welding. So next question is like in which of the process keyhole formation is associated. Options are like friction stir welding, gas metal arc welding, laser welding, resistance plate welding. I think you guys have already solved in the prerequisite, right? And you would have also seen the answer. So if someone knows the answer, can even, yeah, someone has textured laser welding. Yeah, laser welding. Because as I explained earlier, in laser welding, it is a high energy beam welding. Because of that, keyhole formation will form, because of which we can achieve higher penetration. So with the help of this, we can join the higher thick materials compared to electrical submerged arc or gas metal arc welding process or GTW. In laser welding, because of this keyhole formation, we can join high penetration weld will be formed. Because of that, higher thick materials can be joined. If you guys have any doubt, I will wait for 2 seconds in these questions. Let me. I will be opening. Okay, I will proceed further. Next, in eighth question, this is very straightforward. Uh, in arc welding process, the power is estimated. Basically, it's the straightforward formula. The power is directly given by voltage into current. Suppose if you want to calculate the heat input, Then I need to multiply voltage into current divided by welding speed to get the heat input. These are the straightforward formulas in electrical in arc welding process. Do you guys have any doubt? Please text me so that please put in the chat box so that I can see if you guys have any doubt. Basically, this session is meant for problem solving in the sense is meant to solve the problems. In the later stages of this course, there will be a problems where I can solve those problems, which will be more interactive. Since in the first week and second week, most of the things will be theoretical. So I will be only giving these just little concepts of those questions and how to solve those questions. So correlate the in the 10th question, correlate the energy source used for different manufacturing process. So optical sources, electrical sources, chemical sources, and mechanical sources. Electrical sources means just now I explained about the gas metal arc welding, gas junction arc welding, and submerged arc welding, where arc is there means arc welding. Electrical source means arc welding will be used, and optical source in the sense as we know laser welding, optical source is used. So A3 and B1. So A sorry A3 and B1 optical source, sorry, not friction, A4 and B1. So option will be B. Let me check. Option will be B, and we'll check C2. Chemical sources. C2, yeah. Oxy fuel gas welding. Because of the gas fuel mixture, the heat will be generated. Exothermic action will takes place, and because of that, welding will takes place. So this one will be like C2. And then mechanical sources means friction welding because of pressure, because of pressure and and also the friction. There will be a heat will be generated. Because of that, welding will be generated. Because of that, heat will be generated, which makes the welding process. So mechanical process sources will be like friction welding. So the option will be B, A4, and B, electrical sources arc welding. Chemical source will be like laser beam welding, and chemical source will be like oxy fuel welding, C2, and D, mechanical source will be like laser beam welding. If you guys have any doubt, you can ask. Actually, this is a interactive section, so I hope someone have at least answered the question or can ask any doubts. If possible, I will explain this session, or in the next session I will explain the. Okay, no doubt. Okay, I'll proceed further. Someone has raised Saurav, we can text it, or else I can unmute yourself if you have any particular doubt. You can text it in the chat box, Saurav. Okay. For time being, no doubts, right? Okay, I'll proceed further. Actually, he has raised a hand. Okay. Huh. In this question, this is the fourth question of the prerequisite. To estimate the temperature distribution, which one of the following equation is solved? Since you guys are solved, I'll wait for you guys to answer this question, uh, and then I'll explain the equation involved and the boundary condition and all. You guys can chat it in the chat box. Will be texted as A. Okay. Okay, everyone, one more guy is texting A. Basically, this question solution for this is uh, to estimate the temperature distribution, which one of the following equation is solved? Here we use it is heat conduction equation. Uh, this as someone has used option A, this is basically whenever a current is passed, heat is generated. That is called heat is generated. That is called Joule's heating. That is just for you take any conductor, suppose this is a conductor, and if I pass electricity, because of the resistance, the heat is getting generated. That is called Joule heating. Now, this is not this. This is like with this we can't use the we can't determine the temperature distribution. We will use the three-dimensional transient heat conduction equation given by the equation 1, which you guys would have studied in thermodynamics or heat and mass transfer. This equation. Basically, this is a three-dimensional transient heat transfer conduction equation. Uh, this rho is a density, C is specific heat, Q dot is the heat generation, and K is the thermal conductivity, T is the temperature. This is the first equation. And so how it is related to welding, I will explain with the boundary condition for this equation is given by these two, equation 2. So we need to solve this equation to get the temperature distribution. That is understood. This is a three-dimensional transient heat conduction equation. So to solve this, we need to, since ours is like electric arc welding or any deposition process or any arc welding process, there will be a arc because of this arc, the arc or any heat generation. Because of that heat generation, the metal will be melted and deposition happens, right? This equation basically I am explaining for arc welding process, like GMAW or GTAW or like something like that. Here, as we know that suppose if I consider a GMAW process, means gas metal arc welding process, the arc, because of arc will be generated, the metal will get I will show the schematic ones and I will explain the equation. So if you see here, the arc will be generated. Means heat will be transferred from the arc and the metal will get melted and deposited. A metal will get melted and deposited. So after deposition, this portion of the molten pool is getting heated, and this is near to the room temperature. Heat conduction happens, and also since it is exposed to the atmosphere, convection, radiation will happen. So we need to replicate these things in the equation. So I'll explain the equation. So basically, heat loss will happen through conduction, convection, radiation, which will be given by the boundary condition. Means this K and dt by dN will be this is the heat conduction loss through the conduction, and this Ht minus T naught, and this will be a radiation heat loss, and this is the convection heat loss. And the term Qs, this is the heat given by the heat given from the arc to the material. As you can see here, the heat will be given from this particular point to the material, right? So with the help of this equation, we will solve either in ANSYS or even in abacus to get the temperature distribution for finite element modeling based this thing. So this equation is used. So the answer is C. If you guys have any doubt, please put it in the chat box, or else I will proceed for the next question. Okay. Magesh is asking it is only for GMAW process. Oh, not like that. Okay. I will explain the equation. Mainly for GMAW. In other processes also, the heat will be generated at the particular point. So somehow we need to give the heat in this, with the help of this term. In GMAW, as we know, the arc will be in the form of Gaussian flux. So with the help of Qs, we'll give the Gaussian flux with the help of that. Basically, sometimes in laser based, the equation will change. So we need to change this equation. That Qs is there, no? We need to change. For GMW, we'll use Gaussian heat flux. Whether it is surface heat flux, if we use this, if it is laser and all, then we'll use internet. This is like this Q dot is there, no? It will be like heat input per unit volume. Then volumetric heat flow, heat generation means then we'll use this Q dot equation. All you need to understand is like heat conduction equation is used in FEM based simulation, where we'll use this solve this boundary condition. Conduction losses will be given by conduction, and these two terms like convection loss and radiation loss, and heat heat from the arc heat from the arc to the base plate will be given either from the q dot or qs. Based on the process, we will use this process. If it is like surface heat flux, we will use this thing, and this will be 0. And if it is volumetric heat flux, volumetric heat, then we will use internal heat generation in the simulation software or in general, and we will use it 0. So it's based on the process and based on the our knowledge, whether to use this or this. So if you guys have any doubt, let me check. Okay, so I will proceed further for the next question. In the sixth question, it is like material deposition is an integral deposition of the following welding process. This is actually straightforward. So can you please can anyone text, and if you want, I can unmute yourself. You can explain the answer also. So options are laser welding, resistance spot welding, gas metal arc welding, and shielded metal arc welding. Uh, so if you guys text in this, I can unmute yourself. If you voluntarily want to tell the answer, I can unmute yourself. Unmute. Or else, if you don't wish, you can directly. Fonts are very small. Okay. Okay. Anyway, in the next session, I'll correct that also. So in this, I think you are able to see this, right? Material deposition is an integral system of the following welding process. Okay, fonts is also not required. In which of the process material deposition is inherent? Shielded metal arc or gas junction arc or resistance spot or laser welding. Option A, B, C, D. A is laser welding, B is resistance spot welding, C is gas junction arc welding, and D is shielded metal arc welding. So Magesh has said SMAW, Shivraj has said A. So Shivraj Desai is thinking it as A, means laser welding. See, in laser welding, since without any filler metal we can join, right? Only with the help of the high energy laser beam, the material will be fused and joined. There is no external metal deposition is required. It means it's not an integral part. If required, we can use, but that is not an integral part in laser welding. Did you get my point, Shivraj? Yeah, Vasant has stepped as given as an option D. Yeah, yeah, option D. Shielding metal arc welding is the answer, because here we are using as you can see in the figure 11, here the electrode is needs to be melted, because it's a consumable welding process, where consumable electrode, it needs to be melted and deposition happens. So here it is an integral system, whereas in gas junction arc welding, it is like not necessary, because if it is thin plates, with the help of non-consumable electrode, like as I explained earlier, with the help of tungsten electrode only I can join the pieces, right? Metal pieces or material. So not required. Even resistance spot welding, as we can see in this figure, with the help there will be a copper electrode, and it is electrically connected, and whenever I apply the pressure, the circuit will get completed, and because of the pressure and resistance of these resistance of these joints, the heat will be generated, and because of that heat, the material will be melted and joined. So there is no deposition process in resistance spot welding. There is no deposition, because electrode is not getting melted. Because of the heat generated in the workpieces, the joining is happening. And also, as I said, in gas junction arc welding also, it's not required. It's not necessary. It means it is not an integral. So you guys understood, right? Yeah, yeah. GTAW is autogenous welding, so metal won't melt. Yeah. Right. Okay. Next, I'll go for next question. I think this is the last question. Uh, which one of the following types of current is more suitable for welding of aluminum using gas junction arc welding? If you have watched the week one class of week one, there sir has explained which one is suitable. Anyhow, since it was in prerequisite class, I will be explaining. So first of all, so what are the options? DC current, AC, DC with electro positive terminal, DC with electrode negative terminal. So first of all, we'll understand what is this DCEP, DCEN, DCEN, DCEP, AC, uh, and particularly why aluminum alloy is only mentioned, right? First of all, DCEN means electrode will be negative and the base plate will be positive. Electrode will be, once the arc is generated, electrons will be uh, generated from the cathode and it will be traveling uh, towards the base plate, right? And do you guys have any idea about the work function? Yeah, Kuldeep has texted like AC only. Yeah, it's the right answer. Uh, for giving explanation, I am just posing a question. Do you guys know any idea about the work function? Okay. Work function is the minimum energy required to remove an electron from a surface of a metal. So please, it's the minimum energy required to remove a metal electron from a surface of a cathode. That is a work function, right? Okay. Okay. Now, uh, here they have mentioned aluminum alloy, right? Basically, question is like aluminum or highly reactive metals like aluminum, magnesium. This will get exposed to atmosphere. When this get exposed to the atmosphere, they will get oxidized because they are highly reactive. So oxide layers will be formed on the any substrate of the aluminum or highly reactive metal. So oxide layer will be there. Generally, these melting point of the oxide layers will be very high uh, compared to the metal. Suppose if I consider aluminum, the approximate melting point of aluminum is around 660 degrees Celsius, right? But aluminum oxide Al2O3 formed on the surface of the metal due to the exposure to the atmosphere, the melting point will be more than the aluminum. Aluminum, as I said, pure aluminum melting point is around 660 degrees Celsius. But the aluminum oxide which are formed, those melting point will be like around 1500, more than 1000, around nearby 1500 LN. So electrons will be moving from here to here in the DCEN, and once the electron is generated, the temperature of the plate will be increasing near around like 660 or more than that, and melting will happen and joining will take place. But the point is like here, as the surface is exposed to the atmosphere for the highly reactive metals, the aluminum oxide will be formed, whose melting point is more than the pure metal. Means the temperature generated here is around 600 to 700 something like that, but the melting point temperature of the aluminum oxide is very high, so it won't get melted. It forms an inclusion in the molten pool, which is a defect. So we need to avoid that. So we can't use DCEN. DCN. You understood my point here. Since DCEN electronegative, electrons will be generated from the electrode and it will be hitting the workpiece, and metal workpiece will be melting and joining will be happening. But aluminum oxide temperature, as the it is aluminum is highly reactive and it is exposed to the atmosphere, so the temperature will be very high. The temperature will be very high. So it's not possible. The temperature, whatever the temperature generated because of the electron hitting, is not is possible to melt the base plate. So we can't use the DCEN. So next we'll go to the DCEP. But the other important point is like work function for the aluminum oxide forms is very less compared to the metal. Work function in the sense, as I said, minimum energy required to release the electron from the surface of the metal. Since the work function is very less, and in the DCEP or in AC, the base plate will be negative, right? So base plate is negative means electron will be flowing from this to this. So here the point is like work function of the aluminum oxide is very less. So electrons from the aluminum oxide will be released. So surface cleaning will be happening. Means the nearby region where the welding happens, there won't be any oxide layers because the electrons will be released from the since the work function is less. The cathode spot obviously will be in the oxide regions, aluminum oxide regions. So electrons will be released from those things, and it will hit the electrode. So guys, if you have any, how does it is a characteristics of the aluminum oxide, Al2O3. The work function of the Al2O3. Okay, how does the work function of Al2O3 is matter? Okay, I'll explain this slide. See, basically, as we know, aluminum oxide layer will be formed on the metal base plate, right? So here it won't get melted, so aluminum oxide inclusion will be there, so defect will be there in the DCEM. However, the aluminum oxide formed on the base plate here as I said, work function will be less. So obviously electrons will be released from them instead of the pure metal. So aluminum oxide will be removed. That is called surface cleaning. Surface cleaning happening on the base plate because aluminum oxide's work function is less compared to the pure metal. So and then obviously cathode spot in the sense means the minimum energy required to release the electron, right? So obviously from the oxide layer only the electron will be removed. So all surface cleaning will be happening. This is the case of DCEP. Similarly, this is AC alternating current means it will be advantages of deeper penetration of DCEN and also surface cleaning of DCEP. So the option is B. Even though we can DCEP is also an answer, but AC will have a better efficiency than this DCEP. So option will be B, 9B. So I think you guys understood the concept here. If you have any doubt, you can post it in the chat box. Basically, work function of a Al2O3 or any oxide form will be very less. So because of that, the electrons will be released from there. Means the cathode spot will be at the oxide regions. So surface cleaning will be happening in DCEP and also in AC. Since AC has advantages of both things, so this will be used. So AC will be the option. So one more time I'll read the question. Which one of the following types of current is more suitable for welding a flammable alloy using gas tension or welding? So DCEP is possible, but AC has the advantages of DCEN and DCEP. So option is B. I think you guys have understood. If you guys have any doubt, please keep it in the chat box. Let me try to solve. Apart from this, if you have any doubts, other concepts also you can post it. I will try to solve. I will try to explain in this class, and in the next or else in the next live session I will. Guys, basically this session is mainly started from the NPTEL, so that the interaction with the student and the either the teaching assistant will be there, so that more interaction will be there, so the course will be like more interesting like that. Vivek, did you got this your question? Did I answer your question? Okay, I will wait for 2 more minutes. Okay, thank you. If you guys have any doubt in other questions which we discussed in the prerequisite thing, please let me know. I can explain them. Basically, Whenever you're solving the problem, okay, suppose if you are solving this question, first you need to analyze which process this comes from, like fusion welding or solid state welding. Then you can easily answer the question. So that's why I kept this slide of the classification process. So once this question is there, the gas junction arc welding, gas metal arc welding, and laser welding. This comes under fusion welding. So melting will be happening. So fluid flow will be obviously will be there. Friction welding is a solid state welding. Means this friction is here, solid state process. So there won't be any fluid flow. Like this, you need to go for any. First, you need to go for the basics. Then you need to see the process. Similarly for this thing, brazing and soldering. Why the joint strength? Basically, fusion. So main point is like fusion welding and these three points. Fusion welding and allied process in the soldering brazing. So obviously strength will be less because it is like wetting and joining action here, but it is melting and forming a homogeneous structure in the fusion welding process. So like that you need to approach for any process like that. First you need to go out to the basics, you understand the process, and then you need to solve the question. I think no one has doubts. If you have doubt, please let me know. I can catch up on it. And also, sir has uploaded videos. You can watch it and solve the questions. In the next live session, I will be discussing about the mainly about the week one assignment. And also, if you guys want any concepts, I can discuss those concepts also. Someone are joining now. I don't know whether they know the proper time. Generally, this session will be like 6 to 7 in 5 days. Okay, I think like no one has any questions. I'll wait for one more second. I'll start this screen sharing. If you guys have any doubts, you can post or else keyhole principle. Okay. Uh, right now, okay, Vivek, keyhole principle. Next session, I will explain. I will start with this session, means keyhole principle, and then I will go for. Then I'll explain the assignment, like first week assignment. Since the time is also very less, and also I don't have slide for that, so I'll be explaining in the next session. So if you guys have any questions, so you can keep it in the chat box, so I can explain in the next session also. Many of them are joining now. I don't know whether they know timing. Okay. If you guys have any doubt, I'll close the session. Okay. I think no one has doubt, so I'll close the session for now. We can meet it in the next Friday, which we will be using, which I will be solving for the. I will be solving mainly for the first week assignment. This. Okay. And for okay. Bye.